in the board. I can ask anything. I can ask for the acceleration, for mu, for velocity, so you don't know what I will ask. But will be a rolling motion. An object I will throw on the inclined plane, generally speaking, and you will find anything on the inclined plane. Question number 2, free response. The final topic. So if you go to here, to the study guide, multiple choice, the first study guide, you can see here that I divide the study guide in chapter 10 and chapter 11. In chapter 10, mainly was in the first page, kinematics of rotational motion, application of the big three, and the derivative and all this, with the new terminology, omega, alpha, and so on. Changing revolution to radian, so on. The second page and the third page is this type of situation, which will be the first free response, which was what we covered in the previous class. Either this, or this. The rod. That will be the first, which is, this is related to the first and second page. And you have, on the second page, you will have the rod on the, in the first and second page is kinematics, and then this. In the third page, you will have the moment of inertia and the rod, the stick. And now, if you go to chapter 11, in chapter 11, I ask, in chapter 11, on question number 18, so 16 is this. So in chapter 11, you see that 16 is the same than this. 16. Question number 16 is the same than this. But if you go to question 18 and 19, I ask particularly only one question there, a mistake. I shouldn't do that. But you will ask yourself all the questions that I ask here. So in the question 18, if you see, I gave a solid sphere, question 18, multiple choice. A solid sphere of radius r, a solid sphere of radius r and mass m rolls without slipping down an incline as shown in the figure. The question, find the linear acceleration of a center of mass. So what I am asking, I change this by what? The moment of inertia. What is the object that I gave rolling there? A solid sphere. What will be a solid sphere? 2/5 mr squared. That's the only thing that's changing. A good practice will be just to do it by yourself, up to when you understand. And come, and when I give the question, there is no surprise. I told you that will be a question when I give an incline with the radius, the mass, and so on, and find. Now, here I ask to find the acceleration. Do you think that in the test I will ask for the acceleration? Maybe. I can change the figure. But I can change also the question. What question can be? In a multiple choice or free response, what will be the type of question? The acceleration can be one. What will be the rest? Find the force of friction. Find the coefficient of friction. Find the velocity when it's at the bottom of the incline. What will be the kinetic energy of the rotation and kinetic energy of the translation? Of course, in order to find the kinetic energy of rotation, you need to find this. And you need to find the kinetic energy of translation. What will be? What is the kinetic energy of translation? What is the formula? 1/2 mv squared. Can you find the kinetic energy once you found this? It's just to put that, this, my bad, square, this into here. If I put that into here, it will be 1/2 m 4/3 GH, which will be 2/3 mgh. What will be the rotational energy? How much is the total energy? Tell me how much is the total energy. At the beginning, what is the total energy? Which is mgh. Without doing any calculation, if you know that this is 2/3 of the kinetic energy, how much will be the energy of the rotational motion in this particular object? 1/3. You don't have to do any calculation. So if you have the translation, how much will be the rest? 1/3. But if you want to do the calculation, just replace, instead of V, will be what? Omega square R square. Omega square R square. That will be the only thing. And, oh, sorry. Well, because you have this will be omega square R square. BCM. Let me see. Once you replace, if you are rotational, will be 1/2 I. You need to put the I and omega square, which is the B square over R square. And that will give you the 1/3. That gives you the 1/3. So if you put B 4/3 GH here, 4/3 GH, right? 4/3